Hello, I'm Patrick Arlt. I'm the lead designer and developer for the ArcGIS for Developers website. This is CSS for Geographers, which is really just kind of about CSS for anyone. It's just kind of a general, low-level introduction to getting started with CSS and styling web pages and some of the basic concepts and things that you might need to know to get started. And I gave this talk last year and I felt that it was really successful, so I've brought back almost the entire thing verbatim. So if you saw last year's talk, you might want to run over to another session real quick. It's almost slide for slide exactly the same talk again, but it's a good review. It's got a lot of solid information to find again. So I'll put the slides up again at the end if you want to stick around. That's a lowercase L in there, in case you're wondering, so that's avoid a little confusion. So when I see other people start to teach CSS a little bit, I see that there's a lot of focus on tools and a lot of focus on handling all the problems that you encounter with CSS. And we have 100,000 lines of CSS in our site, and this is how we manage it, and this is how we keep track of everything, and this is how we organize it. And they don't actually talk a lot about really the fundamental basics of CSS and getting the properties right and the methods and what the syntax is and where it goes on the site. So this is all about kind of the fundamental level of CSS at the really, really basics for getting started if you don't really know anything else. And there is a lot of supplemental info in the slides. There's a lot of extra links in the slides. There's a lot of links to tutorials and official documentation from Mozilla Developer Network so that you can use these slides really as a teaching resource and as a learning resource to kind of go back through and refresh yourselves and find all these resources. So the slides aren't just for me as a presenter. They're also go back, get the slides, take a look. They're going to help you learn and keep learning kind of beyond this talk. So CSS is tricky, right? It's at best kind of more like an art form. It's not really a computer science. The syntax is straightforward, but it's not always the easiest to get a hold of. There's a lot of odd kind of esoteric concepts from print design, from bookmaking, from the arts. It gets a little sciencey at times, but it's definitely not a programming language. It's not computer science. It's not SQL. And it's one of those things that it takes a while and it takes practice and time to kind of put into it and figure out how this works. So this talk is kind of me trying to condense a lot of that down as far as it'll go into an hour. And you might want to learn CSS for a whole bunch of different reasons, right? We use CSS. It's how we make web pages look how they are. It's how we do layout. It's how we do typography. It's how we do branding, all of that basic stuff. And there's a ton of things we might want to use CSS frameworks. We want to make web pages. We want to make apps like what you saw this morning. That all requires at least some level of CSS. So I want to jump right into the basics. CSS, this slide wasn't in there last year, so it's where the heck do you even put CSS? CSS goes in generally two ways. It goes either inside of a style tag that you put on your HTML page somewhere, and you just write CSS inside that style tag. But most commonly, it goes inside of what looks like a link tag, and you reference another CSS file, and that file gets loaded in. And almost always, you're going to put those link tags inside the head tag of your browser next to your title tag or your description tag or any of the other kind of metadata tags that describe your HTML page. So that's where CSS goes. And this is essentially what CSS looks like. And if you've seen this snippet, if you've ever looked at any of the JavaScript API samples, you'll see this on almost every single JavaScript API sample. This is the code that will make the map go full page. It's very simple. So we start every CSS rule with a selector, and this selector finds those elements in your HTML page. So we're going to get 3 HTML elements. We're going to get the HTML element, we're going to get the body element where the content of the page goes, and then we're going to get whatever element has the ID of map. And we need to apply some CSS styles to those. And those styles are going to go inside the declaration section, which is surrounded by curly braces. And we declare the rules that we want to apply to those elements. So all of these elements are going to have a margin of 0. And then the rest of the CSS rule is just kind of filled out with different variations of this. So all of these things are going to be 100% wide, and they're all going to be 100% tall, and that makes your map take up the full page. And this entire structure is a single CSS rule. And you'll tend to have, on a typical page, you might have hundreds of these rules, or thousands of these rules, or tens of thousands of these rules. It takes a lot of rules to style a web page, to kind of get it to how you want to look. So when you have that many rules, how do you actually keep track of anything? How does the browser figure out from 10,000 CSS rules what a paragraph looks like and what a button finally looks like? And it does this through the cascading part of cascading style sheets. And the browser takes all of these different styles that are defined in all these different places and figures out in what order they apply to a given element. So typically your browser is going to look like this. Your web page is going to have default styles that the browser supplies. It's going to have styles that you define via external CSS files that you include with your page via a link tag. It's going to have styles that you define inside of a style block. You might apply CSS styles with a style attribute on an HTML element. And then finally, there's CSS that you've flagged as, this is really important, guys. You shouldn't ever override this. So this is typically what that looks like. And when multiple properties collide, say there are two different CSS rules that both try to tell us that the background is two different colors, one of those rules has to win, because the background can only be one color. So in the case of a tie, rules with important always win, then rules that you define directly on the HTML element, and then any rules that might be inside of a style tag or a link tag, and then finally the most specific CSS selector will win. And there's generally three styles of CSS selectors. There's selectors that select things by the ID of the HTML element. There's selectors that select things by the class of the HTML element. And then there's things that style by the tag of the element. And this is a really good time. I'll open up this website, which is CSS Explain. If you've ever worked in SQL, this is very similar to SQL Explain. So if you're ever wondering why is ID map, that has a specificity of 1. So it's more specific than something that just has a class of sidebar, which only has a specificity of 1 at the class level. And the less amount of space in this bar, the more specific a selector is. So if I wanted to target all anchor tags inside my sidebar, that's actually pretty inspecific. So in a specificity tie, if two things try to apply the same property to an element, the last loaded rule always wins. So if they're the same selector and they're the same everything, whatever one got loaded last will win in that case. So in practice, if you actually go into a browser, you can actually mess around with stuff yourself. So if you just open up any web page, I'm using Chrome here. It'll be slightly different if you're in Firefox or Safari. Just right-click somewhere on the page and click Inspect. Yeah, should have configured that. There we go. And then this will actually open up the browser's developer tools, and you can actually go in and mess around with the CSS. So if I click on any one of these elements, let's see, where's that header? So this is that header. You can see it highlight there right up at the top. It's where the Esri logo is. You can see what the selector of that element is. So this is the HTML element, then it's inside body.desktop, then it's inside div.app, and then it's inside the div with a class of content, and then it's inside this info pane, and then it's inside this header. And then once you get to that point, you can actually start to look at what CSS is being applied to this specific element. So this element has the position absolute property. It has a left property. It has a background color property, which we can actually just go in and change. So if I want this to be slightly darker, I can say that that's 444. That's the hex code for a slightly darker gray. If I wanted to use color names, I could just say this is dark gray, which isn't really that dark. If I wanted this to be hot pink, we can make it hot pink. So you can actually use your browser tools to kind of learn CSS and kind of inspect what the browser is doing. And then if you actually keep going down, you can see this is where that cascade starts to happen. So this is where the user agent, this is the browser, is telling us that this div is display block. So that display block follows through all of the other rules because none of the other rules override it. And you can take a look at all the rules that apply on this other panel, which will tell you these are all the CSS that applies to this element. And then you can actually click through and see where it comes from. So the display property is block, and that comes from the user agent style sheet. But the background color is hot pink, and that comes from app.css. So you can actually just get started if you want to figure out how are designers on my team styling my story maps. What if I wanted to go in and change that? What if the header was a different color? What if I wanted to make this slightly different? You could just go in and start messing around with it and take a screenshot and send it to someone and say, hey, what if we do this? So that's just a brief little tour of how some of this kind of combines in your browser to make web pages look the way they are. So what I want to do now is we're just going to build a simple app. We're just going to build something that maybe could become a story map template, something that looks pretty simple like what you've seen before. We're going to make it work on desktop browsers, and we're going to make it work when the screen size gets smaller, like on a phone. We'll add some nice colors and some typography to it. We'll give it a nice layout. And along the way, this is how I want to kind of teach you some of the basic concepts of building blocks of CSS. So the first two, these are some of the basic foundational layout bits of CSS that are really good to know, and they're block and inline elements. Every element in HTML is either a block element or an inline element, and there's fundamental differences between the two of them. So I have this demo of block elements, and you can kind of see that block elements always expand to fill their parent container. And they also have a height in addition to a width. So block elements are really the foundational chunks of our website layout. So you can define static widths for them. So in this case, this block, which is I have height or I have width, is always 100 pixels wide. And if I go in and inspect that in the browser, that is indeed 100 pixels wide. So block elements are kind of the foundational chunks. They always expand to fill as much space as possible widthwise, and they always stack below each other as they go down the page. And that's in kind of contrast to inline elements, which usually tend to represent text. So inline elements flow like text, and they have a property that you can use called white space to control how the line breaks, how much should the line wrap or not, things like that. So you can see that I've applied white space no wrap. So all of these things, the lines never ever wrap. And they also don't have top or bottom margins, so you can't space them vertically relative to other elements, but they can have padding. And they can also have margin left and right, as you can see here from these two. So these two, even though they have width and height, they don't apply because they're inline elements. And if I make this a little bit wider, you can see there's an additional property that they're subject to called vertical alignment. And this determines how far up or down the line the inline element sits. So in this case, I've got sub, so that element is going to sit below the line of text that all the inline elements are aligned to. There's also things like super and middle and top and bottom. The default, though, is baseline. which tries to align all inline elements to the same line. And that line is defined by your font in that particular element. So that's block and inline. There's, again, you'll see this on every slide. There's a bunch of resources for you to go back and click through later and just kind of review. They all work. They're all from really good sources that I've vetted. So you can go back and use those to keep learning some of the basics. I'm not going to click through to any of them, but I want to point out that that's there for you as kind of a curated resource. So next, there's always units in CSS. CSS has some particularly quirky little units. So the basic unit is pixels. And pixels in CSS refer to an abstraction that's called device pixels. So I'm on a MacBook Pro that has a screen resolution of something like 100 and 200 and something odd pixels an inch. So 1 pixel on my Mac is actually equal to something like 2.5 CSS pixels. So it makes things appear rather consistent on the internet. So when I say my border is 1 pixel, well, I can't even see 1 pixel on my screen because they're so dense. So that's a useful abstraction to keep track of. There's also percents. So percent width, percent height. There's other uses for percents. Percents are always kind of relative to whatever the parent of the element has. So if I have an element that's 50% of my screen width, 25% of that width is actually, 1/8 of my total screen size. So they're all relative. And this one has this particularly funny little bit. Well, if it's 25% high, why is it only 3 lines high? My screen is clearly more than 25, it's clearly more than less than that. So this actually doesn't work because CSS is originally designed in the context of documents. We wanted to publish documents to the web in the 90s when the internet was just becoming popular. So everything is designed to flow down the page like a document. How long is your document? No one actually knows how long their document is. So how can CSS figure out 25% of unknown? So it just says, now this doesn't actually work. That's why you have to also make the body and the HTML element 100% high in order to make map 100% high. You have to give everything a relative height all the way up your page. There's also other units. M and rem actually come from classic letterpress typography. They're relative to 1 unit of your font size. So on this M demo, the font size is 10 pixels. So 10M is 100 pixels. And we do that because it's actually very easy to size things relatively to font size so that when users increase or decrease their browser's font size, it all scales smoothly. M's are also relative to each other, so now if I make an element that's a child of this, its font size is also 10, so all of its units are going to be relative to 10. So this can get a little confusing, so there's a new standard which is called rem, which stands for root M, which is always relative to the font size that you set on your body element, which is a lot more predictable. So the font size on the body in this demo is 16 pixels, so 1 rem is equal to 16 pixels, so 10 rems is equal to 116 pixels. And then everything is based on that unit of 16. And the last 2 I'm going to show, these are some of my new favorite ones. This is vertical width and vertical height, which are always relative to the vertical height and the vertical width of the browser window. So this block will always take up 25%, will always be a square that's equal to 25% of the width or height of my browser window. So if I resize this and make it wider, you can see that that box that's 25 by 25 viewport widths gets a little bigger. And if I shrink this, it gets a lot smaller. So 1 viewport width unit is equal to 1/100th of my browser window. Just like 1 VH is equal to 1/100th the height of my browser window. And this is really, really useful for making things respond well to different screen sizes, because then you have a unit that's relative to how big the user's device is rather than relative to something on your page or your font size or a fixed pixel dimension. So with that kind of in mind, we can start going into actually building our app. And the first thing we're going to do to lay out our application is we're going to use what's called floats. And floats were originally designed because we wanted to lay out the documents that we were making originally with CSS, like print documents, and we wanted to put images to the left and right of our text and have text flow around those images. And eventually designers got really smart and they said, we can use floats to make really cool web layouts, and thus everyone's hatred of CSS was born. So we have a document here. It's 500 pixels high. And then we have a map element and we have a sidebar element. And this looks pretty simple. We're going to float the map element to the right of our document, and we're going to float the sidebar to the left. We're going to color their backgrounds different so we can keep track of them. They're both going to be height 100%, which means they're going to take up 100% of their parent. Well, the parent of this sidebar element is the body element, and the body element is 500 pixels. So if you guess that sidebar, that's 500 pixels, you can get a gold star. So that's fairly simple. That's pretty straightforward use of floats, but there's some limitations to floats. So now we're going to add our footer for our application, and our footer is going to be pink, and it's going to fill 100% of the width of our document, and it's going to be 24 pixels tall. Now, does anyone actually notice the problem? It's not pink. So why is it not pink? Where did our pink background go? This should be really simple, and this is one of the fundamental problems people have with floats is when you float something, it removes it from the normal block inline flow, because remember, floats were originally for wrapping text around images. So our pink background is actually up here behind sidebar and map. But the text that's inside of our element is flowing around all of the elements that we've floated. So this got to be a little bit of a problem, and developers ended up finding all sorts of ways around this, like using another attribute called clear. So in this demo, all I've done is I've said the footer actually clears both floats. And this says the footer shouldn't be subject to anything that's floated left or right on either side of it. And you can see that that fixes the problem, and now we have our pink footer at the bottom of our page. And this eventually got to be such a pain for developers to remember to always be clearing and floating and fixing everything all the time that we eventually came up with an entire hack just for this called ClearFix. And it was so endemic that you'll see this scattered all over web pages, this .clearfix, .cf. It's everywhere. And there's multiple varieties. There's like 10 different ways to actually do this. And this is my preferred way. There are about 500 more. It's just a class that you can apply to anything that's floated, and it automatically does all that work for you. So what's happening here is it's saying after any element with a class of ClearFix, like our wrapper, insert a dummy bit of CSS that says insert some empty content, make it look like a table, and then make that table clear both, and it clears all the content that's going to come after that and push all that content down. And that works really nicely when you get up to bigger pages and you work with lots of columns and floats and things like that, and you have really complicated web layouts. But if all this sounds a little super esoteric to you and you're never going to keep track of it, in a slide or two we'll get to a way better solution that especially works really well for mapping applications. But not before we have more problems with floats. So in this model, all I've done now is I've tried to add some space around the sidebar and around the footer. And it didn't work out very well for me because my sidebar is now 30% of the width of the screen, and it has some padding on the left and right side, so it's actually more like 30% plus a couple more pixels. And when you have something that's 30% plus some extra pixels plus 70 pixels, that ends up equaling more than 100%, and the browser starts thinking it should wrap things. And that's a huge problem. So we can manipulate this with something called the box model. And the CSS box model is controlled by a property called box sizing. Oop. That was actually the box sizing demo. So in order to control how CSS interprets the size of boxes, we actually want CSS to size our sidebar according to the border. And if I inspect this, this has a pretty good visualization of how the box model is working. So every element has the box model. So in this case, we've set the box model to border box. So when we define width, we're saying the width at the border is 30%. So our padding sits inside our border. So the padding is now 16 pixels. And then whatever else is left inside is up to that. And that entire box takes up 30%, and it fixes our layout. So that's a little bit about manipulating the box model. So the problem is all this is actually very complicated. The box model is complicated, floats are complicated, clearing floats is complicated. This is the basis of why everyone doesn't like CSS. So a few years ago, browser vendors started to realize that we needed different models for laying stuff out on the web. So they came up with a specification called Flexbox. And this says everything is flexible boxes that grow or shrink in different proportions to each other. And Flexbox actually turns out is really, really awesome, especially at laying out full screen applications like what we do with maps. So this is our same layout that we were trying to make with floats and clears, but with Flexbox. And you can see we now have a header, a sidebar, and a map. It grows and shrinks seamlessly. The header and footer are aligned to the bottom and top respectively, and the sidebar and map are growing to take up all of the additional room. So this is what it actually looks like. We have the body of our document, we have a div for our header, we have a div for our footer, and we have a wrapper around our sidebar and our map, and then we have our sidebar and our map. There's not really anything very fancy about this. So we want the HTML in the body to be 100% high. That's a given. And then we have the body with this extra property called display flex. And what this does is it says every child of the body, everything under the body is a flexible box now. And those flexible boxes flow in a column. So they flow down the page. So the header, the wrapper, and then the footer flow down the page. And the wrapper has a flex property, which says the wrapper should grow and shrink proportional to all of the other elements that it's flowing with. It should grow 1 and shrink 1. And if you look at the header and the footer, they have no shrinking and no growing. So they're always their natural size. And then the wrapper is also a flex box, which says all of my children, the map and the sidebar, are flexible boxes. And they flow in a row, so they flow across. And then the sidebar grows at a rate of and shrinks at a rate of 1 to 1, but the map grows and shrinks at a rate of 2 to 1, so the map is always twice as big as the sidebar. So this is, I think this is the most resources that I put on a single slide. Flexbox, it's really complicated. I literally cannot write Flexbox code without going to, I think it's a visual guide. I cannot write Flexbox without actually having this page open and keeping track of all of the properties. I do highly recommend, if you want something fun to do in your hotel room tonight, play Flexbox Froggy. It's kind of like Frogger, but with Flexbox. You have to move a frog to the other side of the road using only CSS, and it's actually incredibly entertaining. There are 24 levels. And it's a very fun way to learn this kind of layout. So now that we finally have this, which is starting to look kind of like the layout we want for our app, we just need to kind of add some spacing around it. We need margin, and we need padding, and some things need borders. So again, Flexbox makes this really easy because nothing breaks. Everything is a flexible box now. So adding 1 unit of padding around our sidebar is actually really easy because all of the other boxes just flex to accommodate the additional padding. Same thing with the map. We can put a margin around the map, and it actually just all of the rest of the document responds to the fact that we added a margin because everything is flexible. So it's a good way to quickly create layouts that aren't going to break like we were seeing with kind of the floats and the clears. So now we can get into some of the fun stuff. Now that we've got our basic layout set up, we can actually do responsive design and respond to different screen sizes. So in this demo, if I pull that all the way out, it won't even go. If I do this. There we go. So that's where we left off in the other exercise. But you can see as I pull this and make my window smaller, we rearrange some of the elements on the page in order to respond to the fact that we're now at a smaller screen size and we might want to present the user with a different layout. And this is fairly easy to achieve using a CSS feature called media queries. So we simply declare @media screen, and when the screen has a maximum width of a certain number of pixels, I just picked 768, it's about an iPad, we're going to start changing these CSS properties. And this is where that selector specificity gets really important, because we want to override things that we've already done to the wrapper. And because this rule inside the media query was declared later than the rule up here, it wins. So we now override some of the properties that we have. So the wrapper that we have is going to flow down. So instead of flowing side to side, the wrapper flows up and down. The map and the sidebar no longer scale differently than each other. They scale the same. And the map also has a different order. Even though the map element comes second, we can say put the map element first and then put the sidebar second. And that kind of finishes out a little bit of responsive design for this demo. So the last thing I want to talk about is positioning. And this is really particularly useful for our application in placing map controls. And this is exactly how the JavaScript API places the map controls that you're seeing, where people put the zoom buttons in the top left and they put the search in the top right. And it begins, we're going to look at our map. It now has position relative. So elements inside of the map are positioned relative to the top left corner of the map. And then we have some other classes. We have 4 of these control classes, which are all positioned absolute. And when something is positioned absolute, it means it's positioned an absolute number of units away from its parent that's positioned relative. And that parent is, guess what? Our map. So now we're able to position all of these controls anywhere we want with pixel units inside of the map. And you can see I just made 4 more classes. We have top, left, bottom, and right, which all have a pixel value. So we're going to position anything with a class of top 10 pixels away from the top. We're going to position anything with a class of left 10 pixels away from the left. And that makes the control top left appear right where we expect it in the top left corner. So positioning is also a pretty nice way to position some of that stuff. So we're going to get into a little bit of design now. Right? We've got our map layout. It works. It's responsive across devices. It flexes to the entire screen. We've really got that dialed in. So now we need to get into a little bit more of the design aspect of CSS. And I've picked some resources that are both free and they're very high quality in terms of picking fonts and colors. So Google Fonts is definitely the big one. Google makes a ton of fonts available for free over the web. They're very high quality. They're well vetted. They're very easy to use, so you can see that I'm just grabbing a pair of fonts from Google and we're dropping them in. You can see me declare using those fonts with the font family property. So our body font is going to be Quattrocento, and the font family of all of our headers is going to be Oswald. And we now have this nice kind of block, and we have this nice sans serif that's going to look the same across different devices. And then we need to get into some other things like sizing typography. And the easiest way to do this is actually with other tools that people who are experts have written, so you don't really have to do lots of thinking, like this one from Typescale. And this is super easy. You can just put in how many units is your base and how big do you want the top to be different from the bottom. And then you can pretty much just say copy and paste the CSS into your document and it all works. It's a very easy way to just apply a bunch of CSS very quickly and size your typography nicely, as opposed to just kind of throwing things out there. So that's exactly what I did here. And you can see now that we have a header 1 that's slightly bigger than our header 2, that's nicely sized with our paragraph. And it all starts to look like it's coming together, except that we're still using gray, blue, and green, and everything is coral, and it's all weird looking. So when you do color, color is another one of those things where there are entire people who just dedicate their entire lives to picking colors. We have colors that are a part of the Calcite web framework that Esri uses. Those are all of Esri's brand colors. They're what our buttons are. You can grab those. Those are good colors to use. There's other color sets people have made on the Flat UI project. I will show you this, though, which is the color pairing matrix. You can just build out a giant index of looking at how other colors look on other colors. And the important thing to think about when picking colors is if the colors you're choosing are accessible or not. So can people with low vision see the color of your text relative to the color of your background? And this is a really easy way to tell that because it tells you right there. So using this light blue on this white is a fail. You probably can't even read that on the projector, which means you know it's a fail. But the ones that you can see are the AAA, which means it conforms to the AAA specification, and it's really, really contrasty and will be really visible. And then if I adjust this a little bit, I can probably get it to drop to AA or AA large, which are slightly less contrasty, but they still work well. So that's really the only advice for picking colors is make sure your colors are visible for people without, with a vision impairment, and keep that accessible. It's fairly easy to do. There's lots of automated tools for it. And there's lots of tools for choosing colors and collecting color palettes and thinking about that. So this is our demo with just a few colors added. So we've got a nice kind of dark blue with a little bit of off gray. That's nice and contrasty. The links have a little bit of color. And the only thing we're left to do now is we have to add some JavaScript to bring in our map, and you target it just like the other 400 JavaScript tutorials will show you how to do that you can go see later. But now you've got a really nice framework to drop your map into and present your content well. So we built our little app. It's responsive. It's nice. It has the JavaScript API, and it has a nice layout and everything. So that's really what I feel like you need to get started. So now it's time for me to tell you what all the pitfalls are. What are the things that you need to know that you should be aware of as you move forward as being kind of this web designer or programmer? And one of them is browser compatibility. Not every browser supports everything exactly the same way. So it's worth it to try to test your website in lots of different browsers. And sometimes browser vendors like Mozilla or Firefox or WebKit or Chrome will add prefixes to certain properties. And you'll see this a lot when you use the Flexbox properties. They might be prefixed with, oh, it's WebKit Flex, which means it's WebKit's experimental version of Flex that you use in Safari. And eventually, as things stabilize, those get removed. So there's websites that you can use like Can I Use or Mozilla Developer Network, which will tell you this is what's supported in every browser. These are what the prefixes are. These are the resources. These are the known bugs. There's a lot of good resources out there as you go forward in testing it. There's also tools. I believe I showed this last year. There's a tool called Auto Prefixer. And this will actually just automatically add all known vendor prefixes to your CSS for you. So if I go to our JavaScript example and I just copy this, let's just take all the CSS from this, and I drop it in there, you can actually see that it probably went through and added, there we go. So it added that MS Flex from Microsoft Flex. And then you can actually tell it to add the support for different browser versions. So I want the last 3 versions of every browser and IE10. And it'll just automatically add that for me. And you can look at the difference and figure out what you need to do. It's a really helpful tool for just quickly making sure that stuff works. So in general, though, if you have a choice, you should only support Internet Explorer 11. Microsoft ended support for all other versions of Internet Explorer last year, and they're not doing security updates anymore. So if you find people in your organization are still using IE10 or IE9, really, I strongly encourage your sysadmins to upgrade them. it's best if they're not on it for security reasons, not even, snooty web developer reasons now where we only want everyone to use the latest browser. It's actually a big risk now. So please encourage that. And then other things you can do is keep things simple when you're starting out. I never had a selector that was more than just a single element. It was always just one thing and then done. That's really simple to keep track of. It's really simple to debug. Always try to keep your selectors as simple as you possibly can because it makes everything easier. They're easier to override, they're easier to find, they're easier to debug. And then don't start with any tools. I showed you the auto prefixer one because it's online and it's really easy to use and it helps solve a lot of problems really quickly. But there's lots of other tools that'll promise to help you write CSS easier and scale your CSS to lots of files and build your CSS and minify your CSS and ensure that your CSS does all these things. And a lot of times when you're just writing a simple web application, you don't need any of them. We wrote an entire application in probably 50 lines of CSS. So it shows what you can do if you actually just know the basics. You can actually forego tons and tons of tools and get something really good really quickly. When you start getting more complex and you start feeling like maybe I can benefit from some of these tools and I have a strong understanding of the basics, then learn one tool at a time. Pick one of the tools that you've seen for CSS and start learning that. And then slowly you can add more tools to your repository. Don't overwhelm yourself trying to compile 4 or 5 different tools all together at once. Just start with one and only start with it once you feel you really are struggling to write CSS. And then the third one, watch out for web fonts. I put 2 web fonts in there and we didn't really see much impact because I'm on the secret presenter demo Wi-Fi that no one else gets. But if you were on the regular demo Wi-Fi, you might have noticed that that page actually loaded very slow because by default, browsers hide all of the text on the page until the font loads. And fonts are fairly large, especially if you're on a mobile device or a slow Wi-Fi network. So it pays to try to use the default fonts that are a part of the browser instead of the web fonts, especially if you're trying to ship to phones or flaky internet connections. So definitely just watch that. Don't throw 5 fonts on a page just because you can, because that page is going to be terrible for everyone except for you on your wired internet connection in your office. So that's all I've got time for. I tried to finish this talk up early so I can take lots of questions, but there are more of this kind of blank for geographers format of talks. This one was successful last year, so John Grava and I kind of brainstormed and we decided to do some additional ones. We have tomorrow night, we're doing Git and GitHub. You can see us do some fun stuff with that. We also have an intro to JavaScript that's kind of similar to this. That's Thursday morning. And then I'm repeating this if you want to tell your friends to come, if you want to tell your coworker to come. This is, again, Friday at 1, so you can find those. And that's it. Please leave me feedback for this. I do go through, I read feedback. I try to incorporate it into my slides. Download the Esri Events app, search for CSS for Geographers. This is the easiest it's ever been. There's no codes, there's no craziness. So please grab that. That's the link to the slides, which has all the links to all the demos, all the resources, so you can keep trying to learn. I'll leave this slide up until I step off stage and have to give it up to the next presenter. So that's a lowercase l because someone will ask me, and that's it. Thank you. So I can do some questions. We have time for questions. So is there any questions? Back. Shoot, I can't hear you all the way back here. So the question was, is there a good way for CSS to do parallax scrolling for fun scrolling effects? You'll see this on a lot of sites. Apple.com does it. Esri.com does it on a lot of pages for just adding effects as users scroll down the page. There really isn't. There's a few things that are specific in Safari that you can use to do it, but in general, it'd be best to either not do it because it's a usability trap. because you're hijacking the browser's scrolling mechanisms for your own purposes. Or if you absolutely have to do it, I would reach for a JavaScript library that's pretty proven out to try to do something like that. So, any other? Yep. So the question was loading indicators, are they good, bad? In general, it's like if you have to show, it's always good to give users feedback, right? So if we see this a lot kind of in the feedback that we get on the developer's website, if you don't give a user an indication that you're doing something on their behalf, they're going to eventually get frustrated. The timeout is actually really, really short. It's like 1 second. Amazon, I think they did some UX studies. They found that every like additional second they took cost them like some ridiculous amount of money, like millions of dollars. So if you have something that's going to take a long enough time for a user to notice that you're doing something, it might be a good idea to add a loading indicator, just because it gives the user some reassurance that you're actually doing something and you haven't just frozen or crashed or forgotten about them. Anything else? This side? Yes?
Given the advent of the Flexbox, is there a reason to go and use a digit border container layout or something like that? Do you have any advice on that?
So the question was, is there really a reason to use a lot of the digit border containers and things that you get as a part of Dojo for stuff like that? The answer could be it depends. The Flexbox stuff is only going to function in, I believe with auto prefixer, you can probably get back to Internet Explorer like 9-ish. It's pretty well supported at this point, and the CSS is a lot more predictable than something like the border container. The border container will give you some controls, so if you wanted to do like the slide panel demos and things like that, you can do some more effects with it, but for basic layout, the Flexbox stuff is really, really helpful and solid. So there are some use cases for it, but I generally would say try to just move to the CSS, because it's simpler to write 2 lines of CSS than to pull in a whole Dojo widget for it. So if that's it, I'll be in the room for another couple minutes. Is it okay to take slides down? Everyone's got that snapped on their phone and everything? All right, thank you.